This is video 11.1.3 on functions, and the goal is to understand what a function is and to be able to find missing input or output values. So, a function, what is a function? That's our first big question. A function is a relation such that there is only one output value for each input value. So when I plug a number in, there's only one answer that I can get. That's key. Okay, there's only one output that I can get. You've looked at some relations in class lately that describe a relation between two variables. X and Y is usually our one. We're using this f of x thing that we'll talk about in just a moment, but it's describing a comparison between two numbers, x and y is typically what we use, where there's only one output for each input. So when I plug a number in, there's only one answer I can get when I do the calculations. So the first question we have is, what is this f of x? The next question. So f of x, you've been seeing this in class. What is this f of x? F of x is just a new way to talk about y. Okay? So it's a new way to talk about y. That's number one. It's just simply a new way to talk about y. And you've heard that it can help so many ways because it allows us to have multiple functions at the same time. Because we use f of x, we use g of x, we might use h of x. And you'll see that come in handy next year and after that when you deal with a lot more functions in your classes in math. It's a new way to talk about y. And it's simply saying f of x means it's a function, so it's a relation where there's only one output for each input, and x is my input. I'm going to plug in x and figure out what the function is, what y is at that particular point. So it's a new way to talk about y, and it helps me describe what I'm doing. So x equals -3. So remember, this is our function relation machine, and where it says x is -3, so that means I'm going to input -3 into this function right here. So I'm going to take -3 and I'm going to plug it in. And I'm going to find f of x at that point. Okay? And by doing that, I'm going to simply do that by doing 2 times -3 minus 4. By simply plugging in -3 for the value. And that will give me my value at -3. And so I get -6 minus 4, I get -10. So f of -3, that's saying the function at -3 is -10. And that's how I would give my answer. The function at -3 is -10. Okay, so we're going to take a look at some more examples just to hear the talking about the math and what it looks like. The next example here is example number 1. We have an input. This time it's -3. And we're going to input it in for x here and find the function at -3. So we're really being asked, what is the function when x is -3? And so I'm going to plug it in. Absolute value of 2 times -3 minus 4. I'm plugging in, absolute value again. I'm plugging in -3 for my x value. And I get absolute value, remember we do all the operation inside, so we're going to get -6 minus 4, which is absolute value of -10, because -6 minus 4 is -10, which is 10. So f of -3 equals 10, and that's my answer. I get 10. So that's my solution. The function at -3 is 10. That's how you would read this statement right here. The function at -3 is 10, because that's what the question was asking. Let's take a look at the next example. So the next example, we have f of x equals the absolute value of 2x minus 4 still. But now we're being told, notice what we're being told. We're being told the output. So we're being asked, when is the function 5? When is the function 5? So again, I'm just going to plug in, but I'm going to plug 5 in for this value. Because that's what f of x equals. I want the function to be 5. I want the result to be 5. I don't know what x is. So my question is really asking 5 equals 2x minus 4, the absolute value. And I have to solve that equation. The good news is you become really good at solving equations like this because of all the practice you've had. So now we're just going to apply everything that we've learned. So let me move this out of the way. We're going to apply everything we've learned about how to solve absolute value equations. So remember, our first step is we have to solve two equations. We want to know when the absolute value, when the inside is 5, but remember the inside could also equal negative 5. So we write the other equation here. And we solve the two equations. So on the left, we're going to simply add 4, 9 equals 2x, and then we're going to divide by 2, and we'll get x equals 4.5. This is one of my solutions. But I could get a second way to get 5. There are two outputs, two ways to get 5 when I plug in two different numbers. Let's see. When I do this one, I'm going to add 4. And I get negative 1 equals 2x. Then I'm going to divide by 2. X equals negative 1 half. So these are my two solutions. Now this seems weird because we just talked about functions and that there's only two of, there can only be one of something, but let's read that definition again. So take a look at this definition again. It's a relation such that there is only one output value for each input value. One output for every input. Take a look at what we have here. We have actually two inputs give you the same output. That is okay, because that's not what the definition is. The definition says if I plug in a number, I should only get one output. Okay, I did not plug in a number. Remember, we were solving for what we should plug in up here. We were not finding two outputs. That would say that there would be two answers possible for f of x. So this is weird because there's two answers, but that's okay because there's two inputs, not two outputs. This says there's only one output value for each input. And so that's why you might have more than one answer for some of these questions. Okay? So that's working backwards instead of forwards. We're finding the input when we're given the output. So let's take a look at the next example. So now we're given, again, we're given the output of negative 4, and we have to find the input. So we're going to, once again, plug in negative 4 for the function, because I know the function should have given me negative 4. I'm trying to find the x. That's my question mark. So I'm going to put negative 4 in for the function and figure out when I get negative 4. Okay, again, I'm going to add 5 to both sides. And I get x squared equals 1. And I bet many of you know by heart that the answer is 1, because 1 squared equals 1. But don't forget your negative answer. What negative number squares and gives you 1? Because what you're essentially doing is square rooting both sides. And the square root of 1 equals 1 or negative 1. So these are your two solutions. So again, we have two answers, but we have two inputs that give me a solution of negative 4. And remember, we can check our answers by plugging in 1 and seeing if we get negative 4, which we do. But we can also plug in negative 1 and see if we get negative 4. And once again, we will see we get negative 4. So I'm checking my two solutions by plugging them in to the function and making sure they give me an output of negative 4 like they're supposed to. So these are some examples to help you get through your assignment. Now there's one more example that I want to talk about, and it's how do we decide if a graph is a function? So we have these two graphs, and here's the question. Are these functions? That's our big question here. Are these functions? So we have to ask ourselves how to decide that. Are these functions? So remember, you did the COLA machine, and it made a function when it was functioning properly, and when you pushed the button, you knew what type of soda you would get. So remember, the buttons are like the X. These are the inputs. So this axis right here is our buttons that we're pushing. And when we push the button number 2, we should only have one soda that pops out of the machine. So when I push 2, notice the graph only has 1 point. So when I plug in 2, I will always get that soda, okay? Or that number in this case. So this is a function because no matter what button I push, I will only get one answer. Remember, one output for every input. They'll only get one output for that one. For this value, my output will be here. One output for every input. So this is a function. Yes, it is. But the other one, let's take a look at this one. This is still a relation. It's kind of like a spiral, we could call it. And if I plug in this right here, I will get 1, 2 answers. If I plug in 3, I will get this or this. It's not functioning correctly. I will get, whoa, which one am I going to get? I don't know which one I'm going to get. So it does not pass the rule. We should have only one output for every input. And we have 1, 2 outputs when we plug in the number 3. So this one is not a function. When we plug in 0, we would get the value positive and then something down here. So this is not a function. So when I plug in a single number, I should always have exactly one answer. Okay? Even if, notice that when I plug in this number right here, I only get one answer. But it doesn't matter if there's one spot where you have a perfect output. You have to have, every spot has to have one output. Every spot has to have one output. Okay? If any spot doesn't have an output, then we're in trouble. So you have to decide by carefully looking at the picture and deciding, is there only one output? So that's a reminder of what is a function and how to decide if something's a function or use function notation like f of x. Be sure to ask your teacher if you have extra questions. But now your job is to complete the worksheet on the back of these notes.